All right, we're going to work with composite functions with our tangent, cosine, and sine inverse functions. So let's review the inverse function for sine inverse and tangent inverse. We nickname that looking at the half moon. We do need to change the fourth quadrant angles so they're negatives. So this would be negative pi over 6. Negative pi over 4, negative pi over 3, negative pi over 2. For the cosine inverse, we're working with the half sun, and we're working with quadrant 1 and 2 only on the unit circle. So here are the inverse properties for a sine function and its inverse. Notice that if you have a sine inverse and the sine of x, your answer would be x, and then vice versa. Same thing happens with the cosine inverse, and vice versa. And then last one, tangent inverse of x, and vice versa. You get x. So what does that mean for our example? So when you do composites, you always work in the innermost parentheses first. So let's start here at the sine of 3 pi over 2. This is not an inverse. This is looking at your unit circle and evaluating for the sine of 3 pi over 2. Your output is going to be the y on your unit circle. So we need to find out where is the sine of 3 pi over 2. So down here is 3 pi over 2. The ordered pair is over 0, down 1. And we're looking for the y. So our y is negative 1. So this answer right here for that green piece is negative 1. Now I'm going to go out to the sine inverse of negative 1. Now sine inverses are looking for the angle measure. So we're looking for the angle measure in these two quadrants. So we look at our unit circle again, and we're looking for the y. Where do you see the y negative 1? Down here is our negative 1, but we have to have an angle that's going from pi over 2 down to negative pi over 2. So we can't choose 3 pi over 2. So our answer is going to be negative pi over 2. So this answer is negative pi over 2. Let's do another one. So you start with the innermost parentheses first. It's saying take the sine of pi. So here's 0, here's pi, and we're going to find out what is going to be the y coordinate at the angle pi. So this ordered pair is negative 1, 0, and that's your y. So we get to replace this sine of pi with 0. And now we work out to that sine inverse. So I'm going to change that to sine inverse of 0. I'm going to create that unit circle again. And now our output should be an angle, because we're taking the inverse of the sine. So we need to look at the half moon. And when would we get the y to be 0? Here's the ordered pair, 1, 0. That's your y. What's your angle here? Well, that angle is 0 radians. So your answer for this composite function, the sine inverse of the sine of pi, is 0 radians. All right, next example, cosine inverse of 0.6. This one we can use our properties up above, right here. So these properties. If you have the inverse of it, then your answer is just x. So the cosine inverse is your x because they're inverses of each other. So your answer is 0.6. Here's another one. Cosine inverse. They are inverses of each other. So your answer is that x value, 1.5.